It is a world-renowned masterpiece. It's almost like the Bible of circuit theory. Professor Hay wrote a very famous book called Engineering Circuit Analysis when he was young. It's almost the Bible of circuit theory. Now, let's solidify our foundation in circuit theory by solving the practice problems in this book. This will help us understand the supply and absorption of power. Alright, I've put an example here. This is 10 volts. This is 2 volts. Well, now you see that I draw a lot like this. And there is a water container here. And a hose over there. So where does the water flow? It will flow from this side to that side, from a high place to a low place. The voltage here is 10 volts. And here it is 2 volts, so the current will flow like this from high to low. But the magnitude of this current is in the region of R, right? R is 4, and V is what we now refer to as potential difference. This side is 10 volts. 10 volts on this side is this ohm. Is now 4 ohm. So this is precisely 8 volts divided by 4 ohms, and we refer to this as 2 amperes. So how can we rewrite this for your understanding? On this side, we sometimes call it a node. And we also refer to it as a junction. This is node 1, here at node 2. So now the voltage at this node is 10 volts. This is 2 volts. The current flows like this. It flows, and in this way, 2 amperes also flow. So, who is supplying the current? Flows out from the positive side. And we say that we are supplying this. The supply goes into the negative side. Of course, in the case of positive current, the positive current that leaves the positive voltage terminal enters the negative terminal. We refer to this situation as supply. And sometimes we use the term delivery, or even the term supply. Then, what happens in the case of this voltage? Here, a 2 ampere current flows into the positive side. A positive current flows into the positive side. This state is referred to as absorption. The absorption 2 volt absorbs, and this 10 volts applies power. Supply. So, who is this in such a case? This one is supplying power right now. This one absorbs. It absorbs. But in what case? You do this every day, right? When you charge your smartphone, then it will charge by receiving current from the outside. And another thing is that power is voltage multiplied by current. Since 2 amperes are flowing at 10 volts, it is said to supply 20 watts. So on this side, the amperes through the positive terminal of this volt, so it is absorbed. It absorbs as much as it was brought in. So here we have 4 ohms and 2 amperes flowing. So in this case, you can think of power as R squared, or you can also think of it as the square of the voltage divided by the resistance. Now, the current is 2 amperes, which makes it 4. Since it's 4 here, 4 equals 16 watts. Which is the resistance. This is how the positive and negative voltage is applied. So, how much resistance is there at 4 ohms when it absorbs 16 watts of power? So, in every circuit, the power supplied must equal what? It must equal the power absorbed. Of course, if I supply 100 but only absorb 50, where does the 50 go? Always remember that. This must hold true. Now, the current here is that IVR in VIR, and since V is IR, That's how the formula comes out. Each of you can apply this according to your respective cases. Now, this is a very simple explanation. But first, a node refers to a point where components are connected. Here too, we have components connected to each other. This is a connecting point too, but it's something you all keep forgetting, right? This is also a joint. This is a node. This is also a node. But isn't this also a joint? That's how it is. This is not a joint. Why is there a small one here? But there's no small one here. So this is just a dot, I mean. So, right now, we have segment 1 here, segment 2 here, and segment 3 here. Therefore, the current that comes in must equal, right? So, it means that 0.2A is going out this way. And what does it mean? When it says 0.2A is going out this way, I thought we were going out this way. But in reality, the direction was the opposite. In such cases, we use a minus, so this is how you all should understand it. So, if you look at it from this perspective, 0.2A is going out this way. And the fact that it's actually minus 0.2A means that effectively 0.2A is coming in this way. How much current is going out this way? It would be 0.35A, right? Next, I want you to consider whether it's supplying or absorbing. Since it's 0.2, it's actually going out like this right now, right? So it's supplying 1 watt. By multiplying 5 by 0.1, there's just 1 volt and actually. And 0.2 is coming in from this side. If it's coming in, it absorbs it. So how much is it absorbing? It's absorbing 0.2 watts. Next, this is currently 0.15 times 4. So what is it actually supplying? The supply is going out like this. So is this now 0.6? Then this is 0.3 from earlier. So try multiplying it. 1.4. If you add everything up, watts is coming out to 0. What happens? That's right. Something feels off right now. You all can try multiplying it by 1. Try multiplying it once. And it's not really that important, then, is it, when such a problem arises? It's the same here. This one is a current source. You can think of a current source as a voltage source, like a battery. So it's very easy to understand. But since we've never seen a current source, we always get confused, right? There is a device that acts as a current source, meaning it only supplies current. As you think about it, there will be 2 amperes flowing here, right? Then, this current will flow like this. And since we said that 4A will come in here, practically, we will see 4A coming out from here. Then we entered 5A this way. So, what this means is that if we say 3A goes this way, it actually means that 3A is coming out this way. So try to match it. 2 goes in this way. 5 goes in this way. 7 goes out to 4. 1 goes out to 3. This is correct. And 7. That's right. So now, what we're looking at here is each component. It's 2 amperes. How does this work? The supply. It's going in that direction, right? Since it's going out the positive side, what is this? Supply. Try multiplying this. One person came. This is 16 watts, and then here at 10 volts. What's connected? Here is also currently 10 volts. This side is also 10 volts. So, since it's coming out at 10 volts. What is this? Supply. How much? 50 watts. This is currently going out. at plus and minus 10 volts. But I thought it was going out, but it's the opposite. So what is this? 40 watts of absorption. And what happens with this? I thought it was supplying power since it goes out towards the plus side. But it actually comes in. So please check if the multiplication results in 30 watts. And whether the total of supply and absorption equals 0. Now, the second part. Is a practice from the professor's book. First, count the number of branches and nodes. This here is a node. A node is a point where components are connected. If you look here, these two are the same point, node 1, and then this and this. So the same point is node 2. Next, you can't miss this one connects to OM and VX. This is node 3. So the nodes are a total of bacteria. The nodes are the world, and then the branches are what we call the connections of the small particles. This is one branch. This is 2, and this is 5. So there are a total of 5. There are 5 branches. This is how it works. And here 9 is 3 amperes. So please teach me everything. It's arithmetic. X is 3 amperes. Now, 3 amperes are flowing this way. So, one more thing to remember here is that since 3A flows through 6 ohms, there is 18 volts here. And the key point is 18 volts. This is what you all know now. At that time, 9 is said to be 3 amperes, and 9 provides the current of 3A, and 18 volts to the blue pair. This is how much current is supplied in amps. So, what is the value of RA? It's just basic math. As for the incoming current, how much is coming in from this side? It's 13 coming in, and 8, plus 13 is coming in, and what's going out is 3, right? 3 Since is going out. We don't know what's below. The current flowing like this is IRA, which is 8. How much is this? You get 18A. If you subtract 3 from 21. So, we just finished it quickly. Now, what is the value below? We know that 18A is flowing here. So what is the voltage drop from here to here? It's resistance multiplied by current. How much is RA? 18A. So, node 1 looks like this. It's 18 volts, and like this, it's 18 volts. That's right, we measured the voltage. We measured a person's height. And when we measured from this side, it was 180, and from that side it was 160. No, it doesn't. Where is there a case like this? It looks the same on the left and right. When you look at the junction from the left, it's 18 volts. So when you look at it from the right, isn't it also 18 volts? It's 18 volts. How much is it for curry? It's 1 ohm. Right? This is a very easy and fun problem. So, what is the second one? I asked again. All right, branch, I'll have the people practice here. Here's one, this one, and this one, and this one. Then, 5 I wrote the same problem again. Now that I placed it like this earlier, so I'm going to draw it again. Now that I've done it, I want to give you all a very important tip. When drawing circuits, draw them in circles to avoid movement. So here, we have 3 joints, right? This one, and the colors. Here and here, this way. This is 1, 2. This is 1, 2. This is 3. If you place it like this, there is 18 volts from the circle. I always do it like this. Next, draw the RA like this. And then here is the VX. Once you have drawn it like this, it will be much less confusing for you. Now, let's spread the blue at 18 volts. Here, you wrote 8 like this, and then over shows here, how much current is coming in, so that's 13A. Next, Since this side is showing 18 volts,
if we find that this point
we
is
can
18
understand
volts,
that the current flowing this way is a three-phase current, right? From here, we will start solving it one by one. It seems like a very difficult problem. But take a look at it these days. If you look at it from this side these days, it's plus 36. Then, since it looks like this, it's minus 42 volts. If you look to the left, it's 32 volts, right? Then how much is it when you look to the right, VRT? Of course, the 32 volts seen from this side should be 32 volts here. Otherwise, it will be a big problem. What is the Vx amount? Now, from here, calculate the voltage that is here. This is plus and minus, but the voltage can be skipped. What about height? Look here. It's set up like this. You can calculate the height like this. The same goes for voltage. The battery will be like this, 1.5 volts. So how much is the voltage? We said it's 1.5 volts. Just like that, when we say Vx, you all will interpret the circuit here. The voltage referred to as Vx is what you see when you look at it this way, and you can write it as Vx when you turn it this way. When I explain, I always say to measure the voltages as you go down from here. So if you look from here, it's 32 volts, and if you look from here, isn't it also 32 volts? Okay, now look over here, this is 32 volts. And if you go this way, it's plus 12, and then what is this? Then plus here we 14. Have Vx. So how much is Vx? It's 6, right? It's really easy. You don't have to do this one, because you can just measure to the left and that's enough. You can go left or right. There's no need to erase both. That's how you should understand it. And one more thing to keep in mind is that whether you come back from minus 32 or from this side, it's the same. So what this means is that this is not something that can be skipped. From here, when you come in like this, it's 0, but when it comes back like this, it's also 0. Remember these two perspectives. Then, naturally, this coming in like this should also be 0, right? You need to understand this well. Now, VR1 is 1 volt. Next, find VR2 What
and
is
V2.
VR2?
Look at this 10 and minus 8. So what would this be? It would be 4 volts. But if you use this as KVR, I'll also tell you how to use it. Now, when you make a full circle, you need to reverse flow. As I pass by like this and enter the plus, I write it as plus 8. So as I enter like this, it's minus 12 volts. And then it comes in like this. Why is it minus? So the minus side has entered. That's right? And then since we added plus here, plus VR2 is 0. So VR2 outputs 4 volts. But what did I do now? Just looking at it from the left, 12, 8 gives 4. You have to buy this. Now I've told you this. And then the Vx is how much? This is 1 round. If you come in like this, you can obtain the Vx. Alright, I'll take out minus 4 volts. Then, if you go in like this, it's plus 7, right? So when you go in like this, it's minus 9. Vx must be 0. So what is Vx? Right now, if you subtract 7 from 13, you get 6. 6 volts. So Vx becomes 6 volts. Now, if you look at it this way, it also becomes 6 volts. Then let's start from here. V2, and then here minus 3 1. This is ultimately Vx. Right. Vx. How much is this? So, since Vx is said to be 6, this is 6 volts. Then, if you calculate again, V2 moves over here. So is it minus 8 volts?
Is that how it is? You can see it as I have explained. Now, next we have 8 volts. Which is the same thing. It's a different issue. It's a different problem. But this is how we look at Vx. Here we have 60 volts, and 5A is flowing through it. So, doesn't this mean there are plus and minus 540 volts here? So from here, it's minus 40. And since this is plus 60, what's the node voltage here? It's 20 volts. So we know that the current flowing this way is 2A. After 2 consecutive losses, 5A came in here, and 2A goes out go out this way. The 3-phase power must go out unconditionally, because what's coming in is the same as what's going out. So the situation here will lead to a power failure. Plus or minus 12. Volts are applied across 4 ohms. And then, what is that one? Now, this is a 3-phase system and Vx is now. Let's start from here. Alright, then let me check the voltage here. This voltage, isn't it viewed like this? If we go like this, it's plus 20 volts, right? This is exactly who I asked about the voltage Vx across the 2A. Current source here. But why are we talking about the voltage across the 2 ohm resistor? You might be curious about this, right? But what did I say earlier? This is the node voltage. If we call this the node 2, the voltage looks the same. Whether you view Vx from this side or from here, since the height is the same. So, everyone, think about it again. When I measured to the left, how much should it be? 180 centimeters. When I measure to the right, then it should come out to 180 centimeters. So, whether you look at Vx from the right, like this, or the voltage across the voltage across this resistor, they are the same. If you understand it this way, it will be very accurate. Next, if you look at this, it shows 30 volts here. And since the battery is connected, it's plus or minus 16 volts. So what is the voltage at this point? Which means it's 30 to 16. So this point is 14 volts, and when viewed this way, it's 14 watts. So how much is this? 14 volts. Then how much is the current flowing through here? 1.3A. So, then 2 amperes came in here. 1.4 is going out here. Then how much should go out here? It changes by 0.6 amperes. Since this is 0.6A, there is A plus 1.2 volts across it, which is 1.2 volts. So to find the voltage here, it's minus 1.214 to 1.2 volts plus 14 volts. Do you understand this Vx these days? Since the voltage measured from this side are the same, you can calculate it like this. Now, shall we try one more? Here, 5A is flowing in this way. And 1A is flowing out. 6 amperes are coming in through here. Now, look at this as well. The point node 1 and node 2 have come in this way. This way, such a king has gone out. The visual fairy went in this way. Then, the side that went in this way. And 6 went in this way. And it went out this way. This means that we can do all of this at once. And change it into 1. How? Can't we summarize this? By saying that 10A is going in. Do you understand? Now, here we have 15 ohms. And here we have another 15 ohms. It can be that simple. If we calculate these two as parallel resistors, it becomes 5 ohms, right? Because divided by 10 times 10 gives us this, is it 20? Divided by the pipe. So, it gets halved. To simplify this further, I will continue explaining this technique. So it goes in like this. And here we have
plus and minus 50 volts, right? 50
So the
volts.
voltage across this is 50 volts.
Why?
Because it's the same
I'm going
thing.
to explain this a lot from now on. But in the case of parallel circuits, the voltage is applied across both sides.
Like how we have 15 ohms connected here.
Here, the voltage is the same, right? And then what else happened?
The combined resistance
also
here
has the same voltage applied. Now, if you look at this
you can see
mathematically,
that
5A is flowing on this side,
and the current is flowing
on the other side as well. Since the two of us are sharing it equally,
the voltage here is 50 volts,
and the voltage raised here is 50 volts.
Since this is the first time, I will only explain
up to this point.
Today, we have looked into our basic circuit analysis methods.
From next time, we will analyze more
in-depth circuits.